discussing the module 6 of the organic chemical technology course, and we already discussed lecture 1 in lecture 1 and lecture 2 about the different aspect of the introduction to the petroleum refining, the various type of the crude oil which we are processing, what are the things that is needed for the evolution of the crude oil, what are the changing scenario in case of the petroleum refinery, and how the quality of the feed that is affecting, or the crude oil that is affecting the further process. So, we discuss in the lecture 1 and lecture 2. Now, we will be discussing about the crude oil distillation, that is one of the major of the you can say the primary operation that we are doing in case of the refinery, that is the crude oil distillation. So, for the coverage of the lecture is concerned, we will have the introduction of the crude oil distillation, impurities present in the crude oil because they play very important role in the further processing of the product which you are getting from the crude oil distillation, because whatever the product you are getting from the crude oil distillation, as such they cannot be used for various purposes, and the some improvement in the quality that has been. So, for that the impurities which are there, which may cause corrosion, which may cause the your catalyst poisoning. So, impurities and their pre-treatment removal, that is very important, and some of these steps in case of the pre-treatment, whether it is at the site or at the refinery, that will be discussing here, and the crude oil desalting process, because there has been lot of the development in the crude oil desalting, but normally because just to meet the requirement of the process, we are having the 2-stage crude oil desalting. Then the crude oil distillation, various steam from the atmospheric and the vacuum distillation column, effect of the crude characteristic on the performance of the distillation. These are the some of the things that we will be covering in this lecture. Let us start with the crude oil distillation. Why the crude oil distillation is there? The petroleum refining process is the separation of the different hydrocarbons. As I told you during the discussion of the crude oil evaluation, the different bases of the crude oil, it may be paraffinic, naphthenic, intermediate base, and it is around, it is reported as the 1000 type of the hydrocarbons that may be there, although it is only C and H, but the very type of the your hydrocarbons are present, and so we are separating some of the major hydrocarbon group which are being used in the as a fuel, which are used as the your feedstock. So, the petroleum refining process, the separation of the different hydrocarbon present in the crude oil into useful fraction, and the conversion of some of the hydrocarbons into products having higher quality performance. So, this is not part of the crude oil distillation, but the product which you are getting from the crude oil separation, that is going for the further processing. Crude oil contains impurities which should be pre-treated before it is being sent to the refinery for distillation process. Refinery costs, pressures, and the increasing availability of the heavy high acid crude, means the high TAN crude at a preferential discounts, are causing substantial changes in the global refinery. Heavy crude production is increasing, and a high acidic crude are growing proportion of the total crude blend which is going to the refinery, and so the pre-treatment that has become very important in case of these crude. Refining of the crude oils or the petroleum essentially consists of the primary separation, which is we are doing in case of the crude oil distillation, secondary conversion process, and we will be discussing in the subsequent lecture in detail of the various secondary conversion process. Already I have given a summary of some of the secondary conversion process which we are using in the refinery. Let us discuss about the impurities which are present in the crude oil and why the importance of the removal of these impurities are there. So, we are having the oleophobic impurities which include the salt, mainly chloride, and impurities of the sodium, potassium, calcium, magnesium, sediments and water, all are present in the crude oil which is creating problem in the further path. Oleophilic impurities are soluble in sulfur compound which include nickel, vanadium, iron and arsenic, naphthenic acid and the nitrogen compound, because these are the impurities which has to be removed to avoid the your poisoning of the catalyst. So, pre-treated oil is used for primary separation process which produce various states and products as the gasoline to lube oils, vacuum gas oils, from gasoline to diesel, or it may be the kerosene. So, various products we are getting. So, pre-treatment is done in two steps. That is, one step is the field separation which is taking place when the crude we are getting after the drilling and the processing of the crude oil for the separation of the sediments, water and the sour gases, that is taking place at the site itself. Just like the Hajra, we are having the pre-treatment facility in the ONGC plant, like that some other ONGC plants they are having the pre-treatment facility. So, the field separation and desalting at the plant site, because the requirement is very stringent in case of the presence of the salt in the crude oil. And so, the desalting, all the refineries they are having the desalting process, they are performing at the site, means in the refinery. The separation takes place on site where crude oil is digged out, as I was telling, that this field separation. In this process, crude oil is filled in large tank and separation of the gas, liquids and dirt takes place with the help of the gravity separation, and so the some of the impurities that we are removing. Even the pre-treatment for the removal of the amine treatment also we are doing for the removal of the sulfur compounds. After the field separation is completed, the crude is processed for the further treatment at the plant site. It is a water washing operation performed at the refinery for removal of the salts like chlorides, calcium, magnesium, sodium and other impurities, as these are corrosive in the nature. So, what are the stages involved in case of the desalting? Desalting process consists of three main stages: heating, because a particular temperature, low or high temperature, that is affecting the efficiency of the desalting process. So, heating of the crude oil, mixing and settling, because the separation of the impurities which is there after the, because what we are doing, we are emulsifying and demulsifying and separating. So, mixing and proper mixing and settling, that is very important in case of the desalting. So, desalting is carried out by emulsifying, as I told you, the crude oil and then separating the salt dissolved in the water. Two phases: water oil is separated either by using chemicals to break down the emulsion or by passing high potential electric current. So, normally we are using the electrostatic de-emulsification, that the what we call the electric desalting process for the all the refineries they are having, and that is the two stage desalting process is there. So, as I told you why the importance of the desalting is there, because the removal of these impurity that has to be done, and the crude oil coming of the free field separator will continue to have some water, brine and other dirt intent in it in spite of the pre-treatment at the site. So, that has to be removed at the refinery to meet the requirement of the process. So, water washing removes much of the water soluble mineral and nitrate solid. There are two types of the desalting which I will tell, the single or the multi-stage desalting. And already I discussed this is a water washing of performed at the refinery site to get the additional crude oil cleanup. Crude oil desalting consists the purifying process, remove salts, reduces the corrosion in the fouling. This is the why the we are going for the desalting. Commercial crude salts contain 10 to 200 parts per billion, earlier it was the 10 to 20 were considered satisfactory low. However, many refineries now aim at the 5 parts per billion, that should be the content, and so the and are even 1 to 2 parts per billion, which is not possible through the single stage desalting. Hence, the 2 stage desalting that we are doing just to meet the requirement of the impurities in the crude, which is being further processed. So, this is about the single stage desalting with the water recycle is usually justified if the salt content in the crude is less than 40 ppm. If the low salt content is there, 2 stage desalting involves dehydration followed by desalting. Double stage desalting is better for residuum hydrotreating, fuel oil quality is better. So, this is the reason why we are having the 2 stage desalting process. So, let us discuss the process. By injecting water, the salt dissolved in the water and solutions are separated from the crude oil by means of the electrostatic separation in a large vessel, which I told you the why we are the electric field high, what is the electric field we are getting. So, the principle of desalting, forming an emulsion when water you are adding, forming an emulsion of the crude and water, and then demulsifying by means of the electric field. This is the procedure, this is the method that which we are using in the case of the desalting of the crude. What are the operating variables in the desalter? Some of the variables in the desalter operation are the crude charge rate, temperature, pressure, mixing valve pressure drop, and the wash water rate, temperature and quality, and the desalting voltage. So, these are the some of the major variables which affect the performance of the desalting process and at the same time efficiency of the your desalting process. Crude oil temperature charged to the desalter is very important for the efficient operation of the desalter. At low temperature, lower efficiency due to low viscosity, because low viscosity then mixing will be affected, all those parameters because of the lower temperature that will be there, and even the settling removal because highly viscous settling. Then the higher temperature, low efficiency due to greater electrical conductivity of the crude. So, this is the reason why optimum temperature that has to be maintained during the desalting process. This is the process which we are using for the crude desalting, that is unrefined crude oil, demulsifier you are adding, then it is going to the for preheating. After the preheating, the process water, that is going to the mixing water, then it is going to 2-stage desalter and the desalted crude, finally it is going to refinery. One of the major problem in case of the refinery is the generation of the effluent which is carrying these impurities, and so this is one of the major problems. So, the proper treatment of the effluent that has to be there, so that we can meet the environmental standard. Now, let us come to the crude oil distillation. Crude oil distillation consists of the because there are 2 units, because what we are doing, we are separating the crude oil into different fraction, and the temperature, that is very important factor, because normally whenever you are going for high temperature, there is always chance of the cracking, that will affect the product quality. At the same time, higher temperature also have the influence on the coke formation. So, crude oil distillation consists of the atmospheric and the vacuum column, vacuum distillation. Why we are going for the vacuum? We know that under vacuum the lower temperature that will be required, otherwise the high temperature, then the cracking reaction that may take place. So, that is why the atmospheric and vacuum distillation both we are using, and that is the integral part of any refinery. Heavier fraction of the crude oil obtained from the atmospheric column is sent to the vacuum distillation column to avoid the cracking at a high temperature, at the temperature around 500 to 550 centigrade we are maintaining in the vacuum dish. Otherwise, the temperature could have been much higher if the vacuum is not maintained. So, that will result in the cracking, which is undesirable part. So, the atmospheric column, what is happening? The preheated desalted crude that will go to the pre-flash section, distillation column, and the stabilization of the naphtha, because the naphtha which you are getting, especially the lighter component of the naphtha, the gases has to be removed from the light gases, especially LPG, that has to be removed from the light naphtha, and the light naphtha again it will go to what we call it the straightened gasoline, which will go to the gasoline pool. This is the actually the flow diagram of the how the crude oil that is going to preheated train, desalter, again preheating in the then it is going to the furnace. After furnace it is going to the atmospheric distillation column. From the atmospheric distillation column you are getting, this is not exactly from this point you will be getting the unstable naphtha, then stabilizer, and from the stabilizer again the gases that will be separated, and the your light naphtha that will be getting. Similarly, medium and heavy naphtha, kerosene, gasoline, light gas oil, heavy gas oil, and residue that from the atmosphere come reduced crude oil. That will again it will be, as I told you, it will be heated and around 500 degrees centigrade that we are maintaining in the vacuum column. The high temperature is avoided just to avoid the cracking. So, from the vacuum column we are having the large number of the products, but whatever the product is there, they are not suitable, they are low value added product. So, to improve the to utilize this, just like you take the case of the light vacuum oil, it will go to the FCC, it will go to the hydrocracker, so that the further improvement that can be done, and then the high vacuum gas oil and the residue which will go to the further processing in the your waste breaker or the delayed coking plant. So, this is the overall, although all the some of the units are not shown here, but it is in the general the block diagram for a atmospheric and the vacuum distillation unit. So, operating, what are the various operating variables, because the operation of the atmospheric and vacuum distillation column, that is very important. And so, in the refinery also, in this separation process, while discussing the your lecture 1 of the introduction part of this course, we discussed a lot of the improvement changes that has been done in the separation process also. Same thing in case of the atmospheric in the distillation column, regarding the packing, regarding the trays, bubble cap to the sieve to the other type of the trays, valve trays, then the packing material, all those things changes that has taken place in case of the distillation column. But this is the actually the some of the parameter, operating parameter, which are going to affect the in separation process in case of the atmospheric distillation column, that the feed rate, desalter temperature, pressure in the desalter, furnace coil outlet temperature, crude distillation column, because the temperature, if you whatever the temperature you are going from the desalter, for it has to be heated, and from after preheating that will go to the your atmospheric distillation. Crude distillation column, top pressure and the top temperature, steeping steam flow, product withdrawal temperature. So, these are the some of the parameters which will affect the operation of the atmospheric distillation column. Now, let us discuss what are the products which we are getting from the atmospheric column. As I told you, we are having the light end containing the unstabilized naphtha, and from the unstabilized naphtha we are separating the gases, the light gases and the LPG. And so, this is the temperature that we are having but you see the gases are below 20 degree centigrade, around 20 to 80, that is the gasoline part of the naphtha, which are directly state-run gasoline, which is having the higher octane number that we are using. So, intermediate naphtha or the solvent naphtha, depending upon, because in the different refinery they are giving the different name. Heavy naphtha routed to the diesel or the naphtha, kerosene, ATF, aviation turbine fuel. The temperature, actually the cut which you are taking, different cut, that the temperature is because some component of the kerosene, some component of diesel, all the things that may be there. So, light gas oil or the diesel fraction, reduced crude oil, which will go further processing, further separation to the distillation column. So, this is the how the various products which you are getting and having the hydrocarbon, different carbon atom will be there, and so that will be utilized for the, just like in case of the naphtha, we are having the lighter naphtha, which called the gasoline below 80 degree centigrade, and that if the higher octane number is there, so directly that will go to the gasoline pole. But if the lower octane number naphtha, normally it is going for the further processing in the catalytic reforming to improve the octane number, or it is made available to the fertilizer plant for the steam reforming for making the synthesis gas, and the fertilizer, or for the naphtha cracker, where we are using the naphtha as a feedstock for the production of the olefins. These are the, I was telling already, we have discussed about the products. This is the actually the your carbon, different carbon atoms which you are getting from the atmospheric distillation column. Kerosene fraction, light gas oil, heavy gas oil, different fraction, this is the temperature range, which I was telling that may vary slightly. Some part of the naphtha, that may be the part of the kerosene, or some part that may be, because suppose if you are going naphtha, you are going to use a naphtha cracker for the production of the benzene or production of the paraxylene. So, different cut of the naphtha that will be taken, because the quality type of the temperature of the actually the composition of the naphtha or the boiling point, that will have the impact on the production of the benzene, toluene or the xylene, which fraction will be more. Now, let us come to the vacuum distillation column which we are using, and again as I told you that the why we are going for the vacuum. You must be knowing that the whenever the vacuum will be there, the boiling point will be reduced, and so the if you are fractionating at atmospheric pressure here also, then the for fractionation of the residue, more high temperature that will be required, and that will result in the cracking. So, to avoid that, we are fractionating the residue from the atmospheric column in the vacuum column. Distillation under vacuum permits the fractionation, as I told you, at a lower temperature, which avoid cracking of the reduced crude oil and coking of the furnaces also. These are the products which you are getting from the vacuum column: light gas oil, heavy gas oil, reduced crude oil, light vacuum gas oil, vacuum slopes, vacuum residue. Light gas oil, that is the feed for the FCC, and now with the coming of the hydrocrackers, we are also able to process the heavy gas oil fraction, or it may be light or the heavy, that may go to the RFC, or it may go to the hydrocracker units. These are the products which you are getting from the vacuum distillation column: the light vacuum gas oil, heavy vacuum gas oil, vacuum sludge, vacuum residue, which will have the bitumen, or it will go to the fish breaker unit, feed to FCC, catalytic cracking, or the hydrocracking units. So, these two are the very important, because you cannot afford, otherwise earlier what was happening, the residue that was being used as a fuel. Some of the fertilizer plant was set up to use the fuel oil, and that was the some of the NFL plant. They started their making ammonia from the fuel oil, although now they have shifted from fuel oil to natural gas or the naphtha. So, that was the actually low value added product, and so to improve the economics, the FCC or the hydrocracker, that has become the integral part of the refinery. This is the operating pressure on the vacuum column. Products from the video already we have discussed, and the temperature, the different cut you are saying, we are getting at a higher temperature definitely, and the feed to the FCU from the light gas oil that is going. Now, let us discuss, because the whatever the crude oil you are getting, they will have the impact on the fractionation, requirement of the temperature, then the formation of the coke in the furnaces, because in the both atmosphere and vacuum we are doing the preheating of the your crude oil in the furnaces, because in the refinery, you see the in refinery you are using large number of the furnaces for preheating, either it may be FCC or it may be the catalytic reforming. So, the crude oil heaviness, that is one of the measurement that I told you, the heavier crude or the lighter crude depending upon the API, that will affect the separation process also. Similarly, the viscosity, a measure of the resistance to flow, and is important parameter for effective desalting. As I told you, the viscosity, low or higher viscosity, they will have the important role in the desalting or the separation of the salts. High viscosity crude need high temperature for effective desalting. There is a limit for the temperature in the desalter, because you see the if you are going beyond the temperature, the separation, again the separation efficiency in the desalter, that will go down. So, this is the why the viscosity or the API, and that is very important in case of the desalting process, because the desalting you cannot look separately from the atmosphere, that is part of the your distillation unit. Characterization factor, already we discussed, it is measure of the paraffinity of the crude. High UOPK is desired for high conversion in the FCC, high UOPK is desired, and the aromatic molecules cannot be cracked in FCC. So, depending upon the characterization factor, you can have the idea of the product which you are getting from the separation. Total salts, that will cause the overhead corrosion, foul up of the exchanger. So, these are the some of the by settling or the scaling that may be there. So, it is removed in the desalter by washing and settling. So, the knowledge of the what is the amount of the total salt, higher if the salt content is more, then more severe actually the operation of the desalter, that has to severe means not the temperature, means the more effective removal of the impurity that has to be there. Total acid number, again total acid number means heavier crude will contain the more higher, and if the acid number means high, means what will happen? That will result more corrosion in the subsequent process. Even we are doing the some chemical treatment or chemical dosing we are doing in the FCC to avoid the corrosion in the FCC, because corrosion in FCC that has been reported, corrosion in the atmosphere and vacuum column that has been reported. So, to avoid that corrosion, that will, because with the help of the TAN number you can the total acid number, you can have an idea of the nature of the crude and the requirement, because the as we are doing the chemical treatment of the product of the crude during before it is going to atmospheric. So, the chemical dosing will be also you can adjust if you are knowing the impurities present. Sulfur is the measure of the sourness and sweetness of the crude pass into the product, because this is the one of the actually the compound which is causing corrosion problem in the process. So, it is removed in the hydrotreaters by reacting with the hydrogen and recover as elemental sulfur. But the sum of the removal, if the more, that will create the corrosion problem, and the subsequent stage definitely that has to be hydrotreated before it is going to either catalytic reforming or the FCC, the feed which you are getting from atmospheric or the vacuum distillation column. The sediments, bottom sediment in the water is a measure of the water dissolved impurities which are there, and so the removal, you can have an idea what is the inlet and what is the outlet content of the desalted crude, and depending upon that you can adjust the condition. So, visio metal is a measure of the metals contain the visio fraction. Nickel and vanadium are known poison for visio hydrotreater catalyst. Now, let us come to the, because as I told you in the case of the atmospheric and vacuum distillation column, we are now the crude which we are using, that is becoming more and more so, means the more sulfur content is there, high naphthenic acid crude we are, high tan number crude that we are processing. So, they always the corrosion that has been reported, and so what is happening if you are whatever the product, and that is reflected in the product which you are getting after the crude oil distillation, and that is affecting the operation in the subsequent stages. Just like you take the FCC where the corrosion that has been reported, or naphtha which is going to the your catalytic reforming, where the catalyst poison, if the impurities, the various metals which are present, and there they will have the, they will poison the catalyst. So, this is the reason why the pre-treatment is needed, and the further chemical injection, some chemicals that we are using for the removal of impurity. So, the chemical injection system consists of the caustic injection and the ammonia injection, and use of the corrosion inhibitor also we are doing, using the use of the demulsifier, addition of the disodium phosphate, especially in case of the boiler feed water. Corrosion in the atmospheric tower overhead system is a common phenomenon, as I told you, because of the crude oil which is becoming more and more so, and the problem is increasing with the increasing use of the heavier crude. So, this was about the crude oil distillation, atmospheric and the vacuum distillation column that we are using for the separation of the crude oil, and the product which you are getting. Some of the product directly it is going for the use, and some of the products just like low naphtha, low octane number naphtha, that will be further processed for improving the octane number in the refinery itself, or it may be used for the production of the petrochemical through the naphtha cracking, or it may be earlier, because the number of the fertilizer plant which came in the early stages, they were based on the naphtha reforming process, and because the naphtha at that time it was surplus. Even you see the history of the cracker plant where we are using the naphtha, that is first cracker plant that was started by IPCL around Nasil, it was the first Nasil, and then followed by your IPCL Padoda. So, at that time, because when the refinery was started, there was no use of the naphtha from the your crude oil distillation because of the low octane number, and many of the refineries at this during the early stages, the catalytic reforming unit was there. So, how to improve? So, this naphtha that was available to the your fertilizer plant. So, this was the actually the, and then the kerosene and the diesel, other some of the, and one another thing that we are using in case of the crude oil is we are using a term state run gasoline, state run naphtha, state run kerosene, means the product which you are getting directly from the distillation of the crude oil from the atmospheric distillation column, or in some of the cases if the cracked naphtha, cracked gasoline, cracked diesel, all those products that you are getting by the further processing of the product which you are getting from the crude oil and the atmospheric diesel. You see, in case of the crude oil distillation, there has been continuous development in case of the configuration of the atmospheric and the in the distillation column. And distillation column, you can say this is the heart of a refinery. Whole efficiency of the separation and the energy consumption, everything that will depend upon the effective operation of the crude oil distillation unit, and at the same time desalting, which is the integral part of the your crude oil distillation.